Hey everyone! Ever wonder how AI models can learn new tasks without forgetting what they already know? Today, we're diving into a breakthrough called Kron-LoRA, a game-changing technique that's making large language models more efficient, adaptable, and future-ready. Let's break down how it works and why it matters for AI's next big leap. So here's the challenge. Modern AI models like BERT or Mistral have billions of parameters. Think of them as massive neural networks with countless interconnected switches. Fine-tuning these for new tasks, like switching from writing stories to solving math problems, usually requires retraining vast portions of the model. That's computationally expensive and memory-heavy. Traditional methods like LoRA, low-rank adaptation, help by only modifying a small subset of parameters, but even that can get unwieldy when handling multiple tasks or drastic domain shifts. Enter Kron-LoRA, a smarter approach that combines two mathematical powerhouses, Kronecker products and low-rank compression. Let's unpack this. A Kronecker product is a way to decompose a large matrix, a grid of numbers, into smaller, structured components. Imagine a Rubik's Cube. Instead of solving the whole thing at once, you break it into layers. Kron-LoRA does something similar for model updates, splitting them into smaller, interlocking matrices. This structure lets the model learn new tasks with fewer parameters while maintaining precision. Here is how it works in 2 steps. 1. Factorization. For each layer in the model, Kron-LoRA decomposes the parameter update into a Kronecker product, essentially 2 smaller matrices. 2. Compression. One of those matrices is then compressed using LoRa's low-rank technique, which approximates it with even fewer numbers. The result? A model that's 4 times smaller than standard LoRa adapters, but still retains the same level of accuracy. Think of it like learning to drive. Instead of memorizing every rule, you focus on key shortcuts, like lane changes or speed limits. Kron-LoRA does something similar for models, keeping the essential knowledge while discarding the fluff. The gains are massive. Take Mistral 7B. A Kron-LoRA adapter with just 5.7 million parameters matches the performance of a larger LoRa adapter with 8 million, while using less memory and only slowing things down by 3.8%. Plus, these compact adapters can be quantized, compressed to 8-bit or even 4-bit, with minimal accuracy loss, making them perfect for edge devices. In experiments across 5 tasks, logic puzzles, context understanding, and more, Kron-LoRA outperformed traditional methods. On DistilBERT, a Kron-LoRA adapter with 0.84 million parameters, 44% of a standard LoRa setup, achieved 49.1% accuracy, slightly better than a larger LoRa model. On Mistral 7B, it used 27% of the parameters but matched accuracy. But here's the real kicker. Kron-LoRA isn't just about efficiency. It's also more robust. When models face drastically different tasks, like switching from math puzzles to medical imaging, traditional methods often forget prior knowledge. Kron-LoRA reduces this forgetting by 3.5 percentage points, thanks to its structured updates. And the applications? They're everywhere. Medical imaging. Tiny, secure adapters could run on hospital devices, diagnosing X-rays without bulky servers. Robotics. A robot arm could switch between tasks in milliseconds, adapting on the fly. Climate science. Simulations that once needed supercomputers could run in real time on smaller hardware. Privacy-first AI. Personal devices could use lightweight adapters instead of sending data to the cloud. Kron-LoRA isn't just a tweak for NLP. It's a universal tool for making AI adaptable, efficient, and ethical. It's like giving machines a flexible brain that can learn new tricks without losing old ones. So what's next? Researchers are already exploring ways to make these adapters even smaller and more secure, with potential uses in space exploration, smart homes, and more. The future of AI isn't just about bigger models. It's about smarter, sustainable ways to adapt them. Thanks for watching.